Question 11. The isotope of hydrogen 1 has a proton number of 1, a nucleon number of 1. Two isotopes of helium are helium-3 and helium-4. So these are the mass number. Okay. Helium-3 has a proton number of 2 and nucleon number of 3. Helium-4 has a nucleon number of 4. Complete the table 11.1 for neutral atoms of these isotopes of helium. To answer the question, I'm going to go through a quick review. So you have a chemical symbols. In any chemical symbols, the Z is the atomic number, and A, which is the mass number, and N, which is number of neutrons. A equals Z plus N, and A, by the way, sometimes the name of nuclear number. Okay, these are the two symbols of helium, so it's He. 2, which is the atomic number of protons or number of electrons, and the 3, because he said the helium-3, the nuclear number, and 3, which is A, and the 2, which is Z. So if you do a quick mathematical calculation, 3 minus 2 give us 1, which is the number of neutrons. For the other helium, the other isotope, which is H24, this is helium, then 2, which is the number of protons, 4, as I said, the number of protons and neutrons. 4 minus 2, it gives us 2. Now, so finally, we can do our calculation. The number of neutrons in helium-3, it's 1. Okay. The number of electrons in helium-3, you know the atom is always neutral, so it's going to be equal to the number of protons here, which is 2. So I'm going to write 2. The mass compared to a neutral atom of hydrogen, so this mass is 3, is triple the mass of the hydrogen one. So it's going to be, if you want to write 3 or 3 times, it's okay. Helium-4, the number of neutrons, okay, so the number of neutrons, 4 minus 2 give us 2, so we have to write 2 here. The number of electrons, as I said before, in helium-3, in the number of protons equal to the number of electrons, so it's equal to 2. The mass compared to a neutral atom of hydrogen, this one, it's 4 times the hydrogen atom, so it gives us 4. So now we get the 3 marks. In section B, an experiment takes place in a laboratory shielded from all background radiation. A sample of radioactive material is wrapped in aluminum foil of thickness 0.1 millimeter. A detector of ionizing radiation placed 1 centimeter from the foil records a reading. A piece of aluminum of thickness 5 millimeter is placed between the detector and the foil, and then the detector reading drops to 0. I think that the type of radiation after placing the aluminum thickness 5 millimeter foil, stopping this type of radiation. So we have 3 types of radiation. All of us were familiar with them: the alpha particles and beta particles and gamma radiation. Okay, anyway, the examiner is asking to state which type of radiation and explaining that this type of radiation which passing through the aluminum foil. Okay, we have 3 marks. We have to determine, and 1 mark, and the other 2 marks for the explanation. Okay, so I'm thinking about the alpha particles first. Alpha particles in general, they have a very limited ability to penetrate the material. So they can be blocked by a sheet of paper, skin, or even few inches of air. For this reason, I'm going to drop alpha particles. I think it doesn't work. So the second option is beta particles. All of us, we know the alpha particles stopped by aluminum foil. So from your studying the last few chapters in your physics book, IGCSE Cambridge, so alpha beta particles now is the correct answer. So I'm going to write beta particles, and this is the symbol of beta. Okay. And beta particles, for more explanation, it's going to be stopped by the 5 millimeters now. So this one, it means that would be stopped by the 5 millimeter thickness of the aluminum foil. And the last option for the gamma rays, we know the gamma rays, it's type of radiation, it's an electromagnetic waves, has a highest level of penetrating the material or penetration. So the alpha particles, the gamma radiation would not be stopped by the alpha particle, will be stopped by the zero point 0.1 millimeter in case one. As I said, stopped by the air or skin, a few inches in air. And for gamma radiation wouldn't be stopped by the aluminum. It's always reduced by the lead. Okay, so we get 3 marks and 1 for the type of beta particles and 2 marks for the explanation.